Good afternoon. I'm Tamar Grainer. This is Turning Data Sideways, Crosstabs and Pivot Tables. And what we're going to talk about in this session is taking your normalized data and denormalizing it in a very specific way where the data values from one or more columns of the normalized data determine what the columns are in the result. We'll talk about this in Visual FoxPro, we'll talk about it in SQL Server, and we'll talk about how to report on these things. As I said, I'm Tamar Grainer. I have been working with FoxPro and Visual FoxPro since the late 80s, done a ton of writing about it. A few of my books are on the slide. Wrote for Fox Rocks and FoxPro Advisor. I'm one of the organizers of this event in Southwest Fox. I was an MVP for a lot of years and received the Visual FoxPro Community Lifetime Achievement Award in 2007. A lot of my work is with other developers where I come in and help in particular areas of a project or just take on additional work. And I'm always interested in hearing about new projects. At this point, I'm going to turn my camera off so you can see more of everything else and get into what is to the session. So here's the agenda. We'll talk about what we mean when we say crosstab or pivot table. We'll talk first in VFP and then in SQL Server. Then we'll talk about the special issues that come up when you report on crosstabs. We'll look at how to do that in VFP reports, how to do that, send the data to Excel, and then we'll talk about making charts and graphs from that data in both Excel and VFP. And I'll stop periodically for questions. So put your questions in the chat, not in the Q&A, but in the chat. And when I stop, Doug will read me at least some of them. So what do we mean when we say crosstab? What we mean is to take data and, as I said, take what would normally be data from one or more columns and turn that into what the columns are. The slide shows a simple example, although we've already done a little bit of processing here, where we have the top browse here is job titles, country, and how many people in that country have that job title. And the data's all there, but it's not easy to read to figure out, okay, what does it look like? The slide, the browse underneath really makes it clear. We have each job title only once, and we have one column for US, one column for UK. And it's really easy to look at that and see the data. Now, for an example as simple as this one, it turns out we don't need anything special. We can just do this manually in a query using the sum aggregation and the immediate if. If it's US, take 1, otherwise take 0, and then you'll add up all those ones for how many are in the US, and then you do the same thing for the UK. And you can do this to get this kind of result, but it really only works with two situations. One is you know exactly what the data is. In this case, you know exactly what countries are in your data. And two, there aren't too many of them. You wouldn't want to do this and have to write that out for 15 or 20 countries. And sure enough, when I run this example, you get the same result that was on the slide. So as I say, that's great if you have only a handful and you know what the data is. What if that's not the case? How do you do this? Well, since FoxPro 2.0, the product has included a tool for making crosstabs. The version before VFP was called GenXtab or Gen Crosstab. When VFP shipped, the PRG had been turned into a class. It's still in a PRG, but it's a class called GenXtab in a program called VFPXtab. The underscore GenXtab system variable points to the crosstab program. And so you can use code like what you see on the slide to create crosstabs. And let's go look at some examples. Suppose what you want to know is for each salesperson, and I should say the FoxPro examples in this session are all going to use the Northwind database. So for each salesperson, how many dollars in sales did they have for each year? And so we can collect the data. This query here gives us one row per salesperson per year. And that is the answer to the question. But what we really want is one row per salesperson with one column for each year, because that'll be much easier to read. So we take this result, and let me go ahead and run this one first, just so you can see. Right, I have to browse it. So here we have one row per employee per year. And again, it has all the data, it's just not very readable. So what we do to turn that into something readable is instantiate the GenXTab object, and it accepts several parameters to tell it what to do. I'm not going to get into those, and I'll tell you why in a minute, but put the result in a cursor called cursor XTab, and the true here means create a cursor, not a table. And then I just call the make XTab method. That's all there is. I'm timing that, and we'll browse the result. So when I run this program, that's a much more readable result, right? One row per employee, one column per year. Easy to pop this into a report, sort of. And if we take a look, we find that wasn't bad. It took 0.07 of a second. But that was pretty small. There were only 9 rows in the result. Let's look at something a little more complicated. Here, what we want to do is get daily sales by employee. Now, obviously, we can't have one column for each day, so we're going to go the other direction. We're going to have one row by day and one column for each employee. So this query is going to pull the data that we want, but again, it's going to be one record for each combination of date and employee. But then we're going to call GenXTab the same way we did before, VFPXTab, the same way we did before, and it will do the crosstab for us. So when I run this, you notice we saw a progress bar. And here we have each day, the column name is based on the employee number and underscore, because of course, FoxPro columns can't be just numbers. They have to start with a character. And you can see that not everybody sold something every day, which is fine. And when we go take a look, that took 0.7 of a second. And while it's a lot bigger than the other example, it's 480 rows, that's not that big. That's because the FPXTab can be slow. And that's why I'm not going to talk about its parameters, because fortunately, we work in the FoxPro community. And when there's something that doesn't work well, somebody builds something else. A fellow in Russia named Alexander Golovlev built FastXtab. Its whole purpose was to be a faster crosstab program. But he also did something that makes it more usable. Instead of having to pass parameters to tell it what you want to do, you can instantiate FastXtab and then set properties to tell it what to do. So in the slide, we're setting the output file, meaning the table or cursor, to the same thing, cursor XTab, telling it we want it to create only a cursor, not a table, telling it to close the original table we passed in, and then we call the run XTab method. So let's go take a look at the same example we were just looking at, daily sales by salesperson. So we have the same query that we had in the last example, but here we instantiate FastXtab from where I have it stored. And then this is exactly what was on the slide, except for the path to the file. Set the output file, cursor only, close the table, run it. And when I run this one, that was pretty much instant. Same results, much faster. So instead of 0.7 of a second, 0.04 of a second, an order of magnitude faster. So FastXtab is great. But this is the FoxPro community. But wait, there's more, because Wilhelm Preissach took FastXtab and improved it and released version 1.6. Since I first gave this session several years ago, FastXtab 1.6 has been added to VFPX, so you can download it from VFPX. It's also included in the materials for this session. And in addition to everything that FastXtab does to make Crosstabs better, it allows you to specify columns, actually rows and columns, by name rather than by their position in the table. It allows you to specify multiple data columns. We'll see examples of all of this. It allows you to specify for each column, are you summing, averaging, counting, any of the aggregation functions, or even your own custom expressions for aggregating. It allows you to filter the data both on the inside and the outside. So let's go look at an example with FastXtab 1.6. We'll go back to the annual sales by salesperson, the first thing we did with VFPXtab. So it's the same query. And the truth is, this code looks pretty much like the code we had for calling FastXtab 1.0, except you'll notice it's a different path. I just put them in different folders, but otherwise the same. And when I run this instant, which it was instant even with VFPXtab, but still considerably faster, about 1/5 the time, 1/4 the time of the original. It was this example up here. So faster even on a really simple example. The materials include the daily sales for using this one also. But let's take a look at some of the other things we can do with FastXtab 1.6. The first thing is every example we've looked at so far has summed the data. We had a query that was sales by employee for some period of time. And when we cross-tabbed, we totaled those up for periods of time. But what if you want to do something else? For example, you might want to count how many of something. Rather than the total dollar value of the sales, how many orders did each person take? Also, as I said, we didn't look at this with VFPXtab or FastXtab 1.0, but you could specify which column from the original data becomes which column of the crosstab. By default, the first data column is the rows, the second data column is the columns, and the third data column is the data that you're going to aggregate. But you can pass parameters to VFPXtab. You can specify properties in FastXtab 1.0 to change those orders using the column numbers. In FastXtab 1.6, you can specify using properties. call field says use this column name or expression, in this case, year of order date, to determine what the columns are in the crosstab. Let's go look at that. So here, this time I'm not bothering to aggregate by year. I'm just grabbing employee ID, order date, and order ID from the order table. I could actually run this against the order table if I wanted. And then in the FastXtab properties, I'm setting the function type to 2, meaning count. I want to count how many orders for each employee each year. The row field is employee ID. I don't have to specify that because if I don't, it'll use the first column of the data. The column field is year of order date. So I'm saying aggregate across years. And the data field is order ID. So what I'm saying is I'm going to count order IDs by employee by year. And then the rest of what's here is the same as before, the output file and so forth. And when I run this, we get 1 row per employee, 1 column per year with the number of orders for that employee in that year. And not surprisingly, it's very fast. What else can we do with FastXtab 1.6? We can put multiple data columns. With VFPXtab and FastXtab 1.0, you can only have one set of data columns. You only do one aggregation, but FastXtab 1.6 lets you do multiple aggregations. So in the example here, we're saying I want 3 data fields, 3 different sets of columns in my result. And then I use the array property AC data field to specify what field from the original we're doing the aggregation on. And I use the array AN function type to say, and what operation am I doing on that data? So what this block of code says is give me 3 data fields. The first one is going to sum order total. Type 1 is sum. The second is going to average order total. And the third is going to count order ID. So what I'm going to get in the query, and let's take a look at the actual query. Again, I'm pulling employee ID, order date, and then summing up the order. And what I'm going to get down here, and this has the same, pretty much the same as what we saw before. I'm setting the row field to employee ID, column field is year of order date, and then the part that I showed on the slide. So what I'm going to get is 1 row per employee and 3 columns per year. The sum of the order, the average order, and the count of orders. And here you can see it. Here are the 3 columns for 1996, the sum, the average, and the count. And then if we go across, we have the 3 columns for 1997 and the 3 for 1998. And that's a fairly, even with only 9 rows, that's fairly complex. And it took 7/1000 of a second. That's really fast. As I mentioned, you can also use an expression for the row. It doesn't have to just be the name of a column. We're not going to look at this example, but it's in the materials. I might decide that what I want each row to represent 1/4 of 1 year. So I have this complicated expression that'll build something that looks like 1998 underscore Q2 for the 2nd quarter of 1998. And it'll use that expression also in how it divides up the data. Another thing that both versions of FastXtab support are what are called pages. Basically, it means allowing us to specify rows by 2 columns, but mentally, you could think of it as almost specifying different tabs in a spreadsheet, different pages. So here we're saying the page field is shipping country, the row field is category name, the column is year of order date. What are we going to do? We're going to crosstab to get the product sold, or the how many products of each category sold in each year to each country. So the query here is going to pull out product name and category name. We don't actually need the product name here. Order date and shipping country, and sum up how many did we sell, and then do all the stuff we need to do to make that query work. And then set the properties. The page field is ship country. The row field is category name. The column is year of order date. And then num sold is the data. And since I'm not saying what the function is, we're going to sum up the number sold. So the total number sold for that year in that category to that country. And the result may be much easier to read than my talking about it. So looks like we didn't start doing business with Argentina till 97. But you can see we have a whole set of rows for Argentina, 1 for each category, then a set for Austria, 1 for each category, and so on down the line. So that's a pretty nice feature. But there's still more. And again, very fast. We can have a custom aggregation function. Suppose what we want to do isn't just sum, average, count, min, or max. In this example, what we want to do is we want to compare how much a customer spent on freight to how much they spent total. So what we're going to aggregate is the sum of the freight over the sum of the order total. What percent of their bill is freight? And so again, this time we're pulling actually not salesperson, but customer ID, order ID and date, and then summing up the order and pulling the amount that was freight. What did it cost to ship it? And in the call to FastXtab, the row is customer. The column is year and month. We're only going to look at 1 year. I think that was in the query that I only looked. No, it isn't. I guess it's going to have all the years and months. And then we're going to say function type 6, meaning custom, use this expression that we talked about already. And when I run that, so for this customer, but you see most of the time a given customer didn't buy anything in a given time. But here you can see this customer in July of 96 had 4.7% of their order total was freight. But in this customer that month, it was only about 3.7%, and so on. And one more thing I'll talk about here, but not demonstrate, is that we can filter both before and after aggregation. The C condition property of FastXtab 1.6 lets us say, before you do the crosstab, keep only the records that meet this condition. So we could have limited that previous example to just 1998 with this expression. The C halving is like having in a VFP query, after the aggregation, zero out or blank any columns that don't meet this condition. So for example, we might have in the previous case wanted to see only the ones where the freight was 5% or more of the order totals. So the bottom line here is if you want to do crosstabs in VFP, use FastXtab 1.6. And Doug, this is a good time for questions.
No questions right now.
Oh, great. Okay, we will proceed then. Let's talk about SQL Server. SQL Server also lets you do what we've been calling crosstab. It calls it pivots. And it's the same basic idea. You take some data, you turn some of the column, you turn the data from a column into actual columns, and you aggregate something. So this is an analogous query to the one we started. The first one we looked at in VFP. We want to know for each job title, this is only part of the whole query, but for each job title, how many employees do we have in each country? And so we're going to be starting with a cursor, which we'll see in a minute. We have the keyword pivot says this is where we're going to, the beginning of the part where we pivot, we have to give an aggregation. Here it's going to be the count of employee IDs. 4, and then we specify what country in the original data determines what the columns will be in the result. The big difference between VFP and SQL Server is this in clause. We have to give it a list of the data values that are going to specify what the columns are in the result. I'll talk about that a little more in a minute. Then finally, we have to say we have to give an alias for the pivot itself. So let's go over to SQL Server, and I have this query already pulled up. In this session, I'm going to use a lot of CTEs, common table expressions, to pull the data that we want to work with before we run the query that does the actual pivoting. In this case, it turns out that pulling out job titles, country names, and employee IDs requires joining a ton of tables. This is a database that's exceptionally normalized. So that's all that's going on here is we're just getting a list of employees, of job titles, job title, country, employee ID. And then we have the part that was on the slide that does the actual pivot. So if we look back at the top of the CTE, there are 3 fields in the CTE result: job title, country, and EMP ID. So what we're saying down here is the data column is EMP ID. We're going to do a count on those. The column field is country, and that leaves the job title field to be the rows. Any field in the data that you use in for a pivot that isn't listed as, that isn't the pivot or the column field, is a row field. So when I run this, I get something that looks a lot like what we saw in VFP. 1 row per job title. There's a lot more data here. All the different columns and how many employees. And it turns out that, in fact, they're all in the US except for salespeople or customer service. I've forgotten which one. Wait, I saw it there. There we go. Sales representatives. Everybody else is in the US. So, as I said, you have to list out the columns. And there's pro and there's con. The big pro is that means you don't have to include them all. Maybe you only want to see a subset. Maybe you only want the European countries here. The downside, of course, is you have to know the data. There is actually a technique that allows you to not have to know what all the data is. And I'm not going to have time to demonstrate it here. It's in the paper. And it uses what's called dynamic SQL. Let's look at another example, just another one quite analogous to what we were doing previously, just to see a simple example. So this is going to be sales by salesperson by year. And it turns out that it's pretty easy. That data is easy to pull out in AdventureWorks using AdventureWorks 2017, but I know it works with earlier and later versions. So we pull the data out, select star means use the columns that we've got. And as I say, anything we don't name down below will become a row. And we're summing the subtotal for sales year in the list of years that I happen to know is in this data set. I didn't talk about the brackets I had around United Kingdom and United States in the previous example. Just as in VFP, when we had numeric data determining the columns, the Crosstab program automatically named the fields n underscore that data value. Here, if we use square brackets around the data values, then they become valid field names, even though they're numeric. You just always have to remember those square brackets. So here we see, again, very similar to what we had in VFP, 1 row per salesperson, 1 column per year. Okay, what else could we do? We could give meaningful names to the columns in the result. Up till now, I've been doing select star so that I didn't have to think about what columns were going to be in the result. But if, as in this case, where I'm doing something monthly, so I know exactly what columns we're going to end up with, we can go ahead and list. You have to list whatever's going to determine the rows. And then I can list all the columns, and I can use the as clause to rename them. So here, we're pulling data out only for a single year. The salesperson ID, the month, the subtotal, only for 2013. And so that's the CTE. And then here in the main query, I'll go ahead and list salesperson ID. And then, as we saw on the slide, rename the data. And that means we end up with a query where the column names are Jan, Feb, Mar, and so forth, instead of bracket 1, bracket 2, and so forth. But of course, you can only do this if you know what the data values are. I've implied this up till now, but I haven't said it explicitly. Just as we were able to do that extra page field thing with FastXtab 1.6, in SQL Server, we can determine the rows using multiple fields. So we can, in this example, we'll get monthly sales by salesperson for each year. And what this query looks like, again, we pull the data, salesperson ID, month of the order, year of the order, and the subtotal. And then that is not. Oh, I'm sorry. Yes, it is. That is the right. I saw the select star and fooled myself. The key thing here is we have 4 columns here. Subtotal is the data column. Sales year determines the columns, but that leaves salesperson ID and month, and sales month of order date. And so they both become row determiners. And we get what we saw on the slide, salesperson ID and month, and then 1 column per year. What else could we do? Something we actually can't do. I'm going to talk about it. So one of the cool features of FastXtab 1.6 was the ability to specify multiple sets of columns in the result. And this slide looks like we've done that in SQL Server. How many orders and the total of the orders. You can do this in SQL Server, but you cannot do it with a single pivot. What I actually did, and the example is in the materials, is I did 2 different pivots, and then I joined the results and listed out all the columns. As I said, we also, there is a technique for handling unknown data. You do it with dynamic SQL. It's in the paper. Basically, you have code that recursively builds a list of the data values, and then you substitute that in. There's also a way, and it's discussed in the paper, to sort of reverse pivoting, to take pivoted data and get it back, not quite to the original, because usually you've already done some aggregation to get to the original because of aggregation, but at least to get back to having what are now column determiners become data. This is another good place for questions. Do we have anything, Doug?
No questions.
Okay. I hope that means I'm being incredibly clear. All right, let's talk about reporting then, because it turns out that when you go to do reporting on Crosstabs, you run into some issues. And we've sort of hinted at what they are already. The 2 real problems. One is you don't know how many columns you have in your cursor or table. And the other is you don't know the names of those columns. And certainly for the VFP report writer, that raises some real issues, because we're used to designing a report and having a having knowing exactly what columns are going on them and on it, and laying them out one by one, putting their names in as the expressions, or putting expressions based on those names. So how do we handle this? Well, I'm going to show a technique that I originally learned from one of the original FoxPro MVPs, Nancy Jacobson. She published an article in Fox Talk in the early 90s that talked about reports as wide as a football field. And the idea is that you break your report into horizontal pages. And you can see this on the slide. 1997 is divided up into 3 groups, each holding 4 months. And then in your report, rather than putting the exact name of a field, you use the field function to find out what the name of the field is, and the eval function to evaluate the field. You use immediate if and print when to determine where there might not be any data. In this example, we're doing exactly a year. We know there are 12 months for a fitting on a page, so you don't have to worry about it. But imagine that instead you were running the years, and you don't know how many years of data you have, and 3 of them fit on a page, but you have 4 years of data. Then on the second horizontal page, you're going to have 2 data columns where there's nothing. So you have to make sure that you have a way of handling that. So let's take a look first at what the report that you just saw on the slide looks like. So looks like an ordinary FoxPro report, right? Until you actually look at what's in these expressions. So let's look at this column. Oh, I apologize. We will come back to that. I want to show you the program that runs this first. So here we're going to grab the employee order date, and we're going to run FastXtab against it. And we're doing 1 year of data, 1997, and columns are based on month. So now let's take a look at how we actually run the report. First, we take the crosstab result and add the employee name to it. That's easy enough. And here's the part that actually is doing the work. Setting up, and turns out I want both the string and numeric versions of the year are going to get used in the report. How many columns are there in my cursor? In this case, of course, I know because it's all the months of 1 year. But in other examples, you wouldn't necessarily know that. I also know that data starts in column 3 because column 1 is the employee name, column 2 is the employee ID. So data starts in column 3. And after looking at the report designer, I said, well, I can fit 4 data fields across. So then I calculate how many pages does that make? That is, if I know there are 14 total fields. We're starting in column 3, so that's -3 plus 1, so there's 12. 4 on a page, I need 3 pages. So then I write a loop, and for each time through the loop, I figure out what is the first data column on this page. So on the first page, it's going to be 3, because this is going to, page -1 is going to be 0, so it's 3. On the second page, it'll be 7. On the third page, it'll be 11, given what I already set up. Now we can take a look at that report and look at what we're doing with those variables. So for the data in the first column, we use the field function for the page base, whatever the first data column on that page is, get its name and evaluate it. And that's what we put in that column. That's the simple case. For the other columns on the page, we build up from page base. So the second column is page base plus 1. And we need an IIF to say, do we in fact have such a column? Does this column exist? So if that number is less than the number of fields total, then we do the same eval of field, except this time it's n page base plus 1 to get the value. Otherwise, we're going to put a 0. But if I put a 0 and actually print that, it's going to show. So in print when, we say that this field prints only if n page base plus 1 is less than n field count. And we do the same thing for the other 2 here, except page base plus 2 and page base plus 3. We also are figuring out what the column headers are. And I'm going to actually cut and paste this because it's complicated and I want to make it bigger. Spread it out. We start with the field name. And we know that the way that FastXtab is going to name a field, the column it creates that has a numeric value, is it's going to put n underscore and then whatever that number is. So we string extract everything after the underscore. That gives us the number, but it's as a string. Then we turn that into a value and we create a date with the report year, that value, which is the month number 1, that's the first of that month. And then C month tells us what is the name of that month. So that's how we get the name of the month. And then the other versions here are the same thing, except more complicated, because they're wrapped with the same immediate if that we have in the data, except since it's character, we can just return the empty string when this column doesn't exist and we don't need a print when. We do the same thing for the total fields as well. And so, having built all that, when I run this, this is the first horizontal page. We might have a dozen vertical pages. In this case, we don't because there are only 9 employees, but we get the January through April. And when I close that, we get May through August. And when I close that, we get September through December. There's another example where, in fact, we don't have data in all the columns on the last page in the materials for this session. I should say that back when I first saw this in the early 90s, it was really an amazing solution. Today, it is not as amazing a solution as we'd like because people usually aren't, they're probably not going to print it out. And if they do, they don't really want to tape it together. In the materials for this session, courtesy of Kathy Pountney, is another approach to the same problem that involves a custom report builder. It's complicated, but everything you need to do it is in Kathy's paper and materials. But these days, people might want other formats anyway. I know that a lot of my clients really want to send their output to Excel. And we have a number of choices for how to put the data out to Excel. The first question is, are we sending the crosstab to Excel? Or are we going to send the raw data and let Excel handle crosstabbing it? First, let's talk about sending the crosstab data to Excel. And of course, what I'm talking about here on this slide applies to anything you want to send to Excel, not just crosstabs. The simplest way is to use FoxPro's copy to function, but it is somewhat limited because it hasn't been updated in a long time. You have 2 choices when you want to send stuff to Excel. You can copy to type XL5 or to type CSV. Whatever you do, don't ever, ever, ever use type XLS. Type XLS is Excel 2.0 format. It's very limited in rows, and more importantly, it cannot handle dates properly. So you can use XL5 or CSV. Probably better to use CSV, but for some reason I decided for this session to show the XL5 code. It's really quite simple. I put the code that actually creates the crosstab, because it's going to be the same for all of these examples, into a separate PRG. And then build whatever file name you want to give wherever it's going to go. And then it's as simple as copy to the name of the output file, type XL5 or type CSV, parens, of course, for a name expression. I'm not even going to run that. So the nice thing is it's simple. It's built in. You don't have to do anything special. But it also creates XLS, the XL5 version of an XLS, but it's still an XLS. And XLSX files first came along, I think, in 2007. It was Office 2007. So your customers may not be real happy if you can't create those. So one possibility is, once you've done the copy to, you can automate Excel, open it up, open the file, and do a save as to store it in XLSX format. That works. The downside is that means that the machine on which you create the file has to be running Excel, which it may not be. There are 2 projects from the FoxPro community that allow you to create XLSX workbooks without having Excel on your machine. The first is XLSX workbook. It comes from Greg Green. It is in VFPX. And it's a class that will do the conversion. It also has the ability to convert a grid to a workbook. And it has ways that you can do formatting. To run it, the simplest version, the code is not much more complicated than what we just saw for copy 2. Run your code to create your cursor, figure out where your output is going, and then you instantiate VFPX workbook XLSX and call its save table to workbook EX method, passing in the name of your cursor or table and the name of the output file. And that will create a workbook for you without having Excel on your machine. The other one of these comes from Wilhelm Jan Presach, the guy who created FastXtab 1.6. And this is DBF to XLSX. It's a program, and it's part of a suite of programs that do conversion between Excel and VFP. So pretty much the same code, except this time we call the appropriate PRG. It's called copy to XLSX, passing in the cursor name, the output file name, and the third parameter here indicates whether you want to include the column names as headings in the spreadsheet. Again, I'm not going to run it, but I'm not running these examples because they're not very interesting. But there's another option when it comes to Excel. Excel has this very nice ability to create pivot tables, where pivot has the same idea as in SQL Server. There's a wizard that creates them, and if you've never played with it, it's worth spending some time with it. And if you create a pivot table from new data, rather than just exporting the crosstab data, it gives your customers opportunities to do their own slicing and dicing. So you can create something like what you see on this slide, and you know what, we'll look at what you can do with it once we've done it. Now, this is something you do by automation, so you do have to have Excel available. And so here we're going to pull the data. Employee, it's again employee sales by month, by year. We'll add the employee name. And then we're not going to crosstab. We'll create a CSV file. So copy to type CSV. And then we instantiate Excel, open the CSV file in Excel, make Excel visible. Then use this lovely method of Excel called used range, which selects, or in this case, creates a range from exactly the part of the active sheet or whatever sheet you apply it to that's in use where you have data. We're going to add another sheet to this workbook, give it a name, and then comes the magic part. We're going to create what's called a pivot cache. So there's a pivot caches collection of the workbook. You call its create method. One says that you're using Excel data. That one is the first parameter. Then O-range is where that data where is the data in Excel. And then you give a pivot table type. For reasons I don't remember, chose the slightly older Excel pivot table 14. So what this does is it takes your data and sets it up so you can then use it to create as many pivot tables as you want. Once you've done that, you go to your pivot cache, call its create pivot table method, tell it where to put the pivot table, what to name it, and the third parameter isn't relevant here, and then the fourth parameter is the version, same as before, Excel pivot table 14 in this case. Once you've done that, if you took a look at Excel, you'd find that it looked just like it would interactively at the point at which you've started the pivot table wizard but not specified any data for it. Then we have to go ahead and say, well, what are the rows? What are the columns? What's the data? So first we'll add a data field. And the pivot table has a pivot fields collection based on the data it was handed. We'll take the one called order total. That's the one we want to aggregate. It's the data. We're going to rename it as orders $, because that's going to show up in the work. That's going to be a caption in the worksheet. And this value is the Excel sum constant. So we're telling it that the data here is we're going to sum the order total field. Once we have renamed this field, anytime we want to refer to it, we actually have to use this new name. We'll see that a little bit further along. We then go into the various fields in our pivot table and tell what role they play in our result. So the one called CNAME is going to specify the rows. CNAME is the name of the salesperson. So we're going to use that as a row field. We only have one row field, so it's position 1. We're then going to take the year field and say that's a column field. It determines columns, and it's the highest level column determinant. And then the month one is also columns, and it's the second level column determinant. Then I just specify some headers, salesperson, months/years, and I format our data. Notice I'm referring to that same pivot field that before was called order table, and now it's called orders $. And this format is a nice format for getting money amounts to look good. So when I run this, did I hit it? I don't think I did. Oh, yeah, it's running. So when I run that, Excel is now open and showing us the workbook we just created. Notice there are 2 tabs. We're in the one called Sales Pivot. Here's our orders $, telling us about this. Months and years, salespeople. Notice it automatically totaled each year. Notice also I can expand and contract, collapse. So I could collapse each of these years if I wanted to. In these drop downs, there's filtering available. I'm not going to go into it in detail, but you can limit what you see. You can limit based on values, based on the names of things. And the same deal over here, so I could eliminate some of the salespeople. Notice also that the pivot table wizard appeared when I started playing with this. And that's kind of nice because it means that your customers could take what you've given them and then they can try other things that might be important to them that they might want to see. So that's really quite cool. This is probably a good place to take questions if there are any.
There were a couple questions, but it looks like they've been answered.
Okay, cool. Thank you all. Okay, so that's creating spreadsheets. But of course, another thing people might want to do is charting. We'll start with Excel, and then we'll talk about charting in VFP since we're already on Excel. It turns out that to create what are called pivot charts requires only one more line of code after creating a pivot table. Excel has incredible charting capability, dozens of kinds of charts. The example on the slide, and we'll see this in VFP as well, is how many we sold in each category to each country. We saw that earlier, the product sold example. Oh, wrong. Going back to VFP. So here's how we create that as a chart in Excel. Again, we're going to pull, this is the same data we pulled earlier for the product sold. And we'll do the same thing we did in the last example. Copy the data out to CSV, open Excel, open that CSV file, make it visible, add a worksheet, give it a name, grab the used range, create a pivot cache. I mean, this code, other than the few names of things, up till here, it's really the same. We'll create the pivot table. Again, we're giving it a slightly different name, but that's all. And then we have to go ahead and specify in this example, what is the data? What are the columns and rows? So the data is num sold, which we'll call units, and we'll sum it. We're going to specify the category name as the row field and caption it category because we're going to create a chart. We need captions. We're going to specify the shipping country as the column field and call it country. And then one more line of code, just add chart. The first parameter is the chart type. This time I'm creating something it calls a column clustered chart. That's a bar chart in groups. And then these parameters are just where it starts and how big it is, where I'm putting it on the worksheet. So when I run this, first thing to notice is that our pivot table is behind it. And if I position this differently further down on the page, which I could move it, then we'd be able to see the whole chart. But here's our chart. Slide down a little. And we have categories along here. We have a legend of the countries. If you hover over a data point, it will tell you this is USA meat poultry with 1,157 units. As in the pivot table, you have filtering available. And in fact, you can do filtering of either one programmatically with automation. And filtering of the countries as well. Same ideas. So it's pretty cool. There is an example in the materials of actually automating the filtering process. And you can create all different kinds of charts. If you right-click on here, you can see just all the gazillions of kinds of charts. I'll just make one minor change just so you can see how that looks. So now it's 3D. So it's really, once you're creating pivot tables, creating pivot charts is piece cake. Okay, but what if you don't want to use Excel? Well, one of the nice things we have in VFP is the Fox Charts tool. It's a VFPX tool for creating charts. It's based on another VFPX tool for doing graphics. And the way Fox Charts work, and this is a very surface level because it's a very deep product, is there is a container. You put this container, which is the Fox Charts container, onto your form. For this session, what I did was I created a form class with the container on it. And I created at the form level a method called make chart that I call from init to do the actual charting. You can actually do some of this in property sheets, but I find that it was easier to create, at least for demonstration purposes, to create this make chart method. So we're going to do the same example we just did in Excel. We're going to get the product categories by country, by year. And we're going to do the crosstab with FastXtab, and then we're going to configure our chart. There's only one column in the result cursor that isn't the name of a country. It's the category. So we're going to find out how many countries do we have. We're going to caption the form category sales by country. And then with the charting container that I've got on the form, I'm going to anchor it. Chart type 8 multi-bar is the closest to what we had in Excel. Going to use a default color set 0. The data is coming from Cursor X tab. And one of the axes, we're going to have the category name. That's going to be the horizontal axis. And I'm going to actually show the name, and I'm going to rotate them 45 degrees and right align them because the names are too long to fit across. They'd overlap. So by putting them on a 45-degree angle, it looks pretty good. The charts count property of the Fox Charts object isn't how many charts you're creating, it's how many data series there are in the chart. And we're going to have one data series for each country. So we're going to set the count to as many countries as we have. We know that that data begins in column 2. And so we're going to loop through all the countries. And using the fields collection of the Fox Chart object, we're going to specify information for this particular series, this country, what the value is which is the field. We're just going across one row, one column at a time. And the legend is going to be the same thing, the name of the field. Then I'm just setting up some captions. Once that's all set up, I call the draw chart method, and the work gets done. It just happens, and it's really very cool. What just did I? No, there we go. And here you see we have our legend, our names here at a 45-degree angle, right aligned. We have our countries. If I hover in the right place over one of these, it will show me the data value. 1524 USA. This one is 1027 Austria. Now, what we don't have here is the ability that we had in Excel to do our filtering right on the chart, or to change the chart type right on the chart. I guess we could program some of that. But as in Excel, there are many different chart types built into Fox charts, many options for customizing what you see. More try. I didn't go to this. So, crosstabs and pivots let you show data in a way that users often want to see it. This is a very common request. And as we saw, there are a lot of different ways you can then output the data once you have created it. Are there any final questions?
No questions, just a couple of comments. Slobodan said, I suggest putting Excel.visible true as the last action in the automation, the speed issue, and Lutz added onto that, and to minimize the risk of a user clicking into it.
Yeah, that's a good point. And I imagine when I first wrote that code testing, I had it up high because I wanted to look at things as I went. But yes, absolutely. When you are automating Word or Excel or pretty much anything, going visible as late as possible is a good idea because it will be faster.
The other comment is actually mine. You said it would be nice if there was a way to change the Fox chart, and we could code it. Actually, Jim Nelson already has one of the add-ons I think that comes with Fox charts is a tool that interactively allows you to change the chart type and pretty much every property that you do programmatically.
Yeah, and I actually meant to mention that. Yes, when you install Fox charts, you get with it this great tool to help you build charts. I don't know if people are giving that to their clients or not.
Actually, a couple more questions just popped up. Richard asks, can you create a dashboard of charts on one form?
I don't see why you couldn't. I mean, it's just code. I mean, like put multiple Fox charts objects on a form. I haven't done it, but I don't see why you couldn't. Do you know, Doug?
You certainly could, because a Fox chart object is really just a shape object that has special code in it. So you could have multiple instances of it on the form.
Yeah.
Shannon asks, is there a performance hit when using XLSX workbook or DBF to XLSX with lots of rows?
I don't think so. I think they're pretty quick because what they're doing is they're actually creating the raw data file. You know, the XLSX format is an XML variant. So they're just building that XML. So I don't see why it would be slow. I don't know that I've tried it with enormous files, though.
I have, and it's pretty quick. I mean, I haven't used DBF to XLSX, but I have used the Greg Green's one, and it's pretty quick.
Okay. That's it?
That's it for questions, yeah.
Okay, well, I will pop over into the Q&A session room in case people have additional questions. Thank you all very much. Please fill out your evaluations. I learned from them and look forward to chatting with you all.